Hi there, I currently own a RAGLAN 5-inch centre lathe and I'm about to change the two drive belts on the fixed pulleys. Now, recently I've produced 5 videos with regard to changing the variator pulley belt, and if you've watched those videos you'll know somewhat of what the machine actually consists of. But if you haven't, then come across and have a look at this, because I think some of this might be fairly important, to be fair, in my opinion. So come across and have a look at these sketches that I've done, and I'll talk you through what I'm going to do and what my concern is if I don't do what I'm going to do. So I hope you can see these sketches okay. They're not to scale or anything like that, they're merely sketches and that's about it. But what we're looking at here, we're looking at the lathe as if we were stood from the front of the lathe looking at the lathe. And here we've got the chuck on the right hand side. This would be the chuck of the lathe, and this would be the shaft that the chuck sits on, and it goes through a bearing in the headstock here, this being the front headstock of the lathe, this being the front face of the headstock of the lathe, and this being the rear face of the headstock of the lathe here. And basically we've got the chuck here on a spindle, and the spindle goes through the bearing, and then it's onto a fixed pulley, and then a fixed pulley, and then there are several gear wheels in the headstock, and then again it goes into a bearing which again is mounted in the external face of the rear face of the headstock, as it were. So that's the front face of the headstock with the chuck, that's the rear face, and the bearing in each face there, supporting this shaft and all the ancillaries that are on it, the gears, etc., and these pulleys. And then we're looking at it this way from the front of the lathe, and so all of this is above all of this here. And what there are two belts that link this fixed pulley to this fixed pulley here. There's one belt on that pulley, and there's also one belt on this pulley here, which makes 2 belts in total. So this here, if you've seen the other videos that I produced about the variator pulley, this then goes back into the lathe. The belt on this pulley goes back into the lathe, to the back of the lathe. But these pulleys, these belts here, come up and attach onto these pulleys here. And as we can see, at this end of this shaft, we've got a bearing in the front face and a bearing in the rear face, as I've said. But on this one, if you recall, if you've watched the other videos, and I recommend that you do, because if you don't watch them, you might miss out on some bits that you need to know when you're changing the variator belt, which I found quite difficult to do with quite a few hidden screws, etc. But what I found whilst I was doing that was that this end of this shaft here, because we've got a bearing here external of this face here, which is the end wall of the lathe, we've got a bearing mounted on the outside of it, and that bearing is mounted with 2 screws, or 2 bolts should I say, screwed into this casting of the lathe. There go the threads, and it's bolted into this casting of the lathe here. And the idea of it is that this bearing here can be moved slightly, it can be tilted, etc., to allow this end of the shaft to droop down a little more in the headstock. Because what happens is, and that's, I'll just tell you just now, my lathe has been running with one belt on here for quite some time, and had I known how the lathe was constructed, I wouldn't have been running it with the one belt, because I think that's quite dangerous and you may cause work for yourself if you rely on just one belt, because I don't think that two belts would really be required to get the amount of drive that you need into the chuck. But I think really that Raglan have designed this with two belts, because these pulleys here being fixed in these bearings here on the shaft, they form actually the bearing for this end of this shaft, because if there were no belts on there, this shaft would tend to drop into the bottom of the lathe. How far, I'm not really sure, but my real concern is, now I know how this lathe is put together, that if both belts snapped simultaneously and this shaft was allowed to drop down uncontrollably while still spinning, because this variator pulley connected to the motor at the back would still be spinning this shaft, these might tend to start flaying around a little bit inside the headstock, which might not be too big a problem, but in doing so, this being a variator pulley, this sidewall here moves in and out and in and out, and what makes it do that is this system here. It's a fork, and this is what the fork looks like. So that's the shaft there, the round shaft, which we're emulating here with this. And basically what happens is the two screws here, which can be screwed into or out of this fork arrangement, and I guess what should happen is these should be set so that they're pushing exactly parallel on this face of this thrust bearing. This here is a thrust bearing that forces this side of the pulley in or lets it come out. So my thoughts are, if these were to uncontrollably be allowed to drop down into the bottom, what would happen to the alignment of these screws and this thrust bearing here? That might, the outer shell might come off, and the ball bearings inside here would tend to fly out and come apart, and then you would need to buy a new bearing for here and fit that, which would be a lot of dismantling of this side of it to get that system put back on. So I haven't done anything with my variator pulley this time, this thrust bearing this time around on the inside variator pulley. I've left it well alone because it's never caused me any trouble up to press, so I've just left it well alone. On the outer one, on the motor at the back, I've greased all that up because I could get to it quite readily, and that was the first time I'd ever seen what a thrust bearing actually looked like. But inside there are a lot of round balls, all rotating between this face of the thrust bearing and this face of the thrust bearing. And if this shaft was allowed to drop, all of this might shake itself apart, all the balls would come out and that would be destroyed. And it's quite an old lathe, obviously, so whether you can actually get the same bearing, I'm not sure now. It might be that Tony at lathes.co.uk could supply you with a new bearing, or you may have to get a nondescript bearing. But in any event, if that did actually come apart and be damaged, it would need replacing. And currently, just to change these two belts, which go from one pulley to the other, it doesn't need any alignment or change, and it seems to be working okay. So I'm letting sleeping dogs lie on this one. But when I did my variator pulley, I inadvertently ended up putting this V-belt back with a twist in it. So I've got a twist running in that belt at the moment. But for long enough I've been running it with only one belt. not knowing that there was a potential for this shaft to drop down and destroy that bearing effectively. So now I know that, what I'm going to replace both belts, but as we can see, there's a bearing here and a bearing here, and the two bearings would need dismantling so that all of the shaft could be withdrawn out of the lathe, etc. All these gear wheels would have to be loosened off, and these pulleys here would have to be loosened off, just to get this system out, such that you could get access round here to put the belt on. If you put, there are belts that you can get which are a full, the pulley there and the pulley there, you can get a belt and it will be a full belt like that, but you would have to remove the bearing and take that shaft out so you could get one of the full belts in. Now Tony at lathes.co.uk does actually sell these belts because they come in a matched pair, because they need to be the same length to give the same friction on these fixed pulleys and hold it in a parallel relationship to this one here. But what I've decided to do, I don't want to remove these bearings and perhaps have to replace them if they don't go back together correctly. And to me it seems a very big job to dismantle all that shaft and these bearings, etc. So I'm frightened of doing that. I'm not going to do that. I'm going to buy what's called a T-link belt, which is, I'll just do another drawing there. A T-link belt is just a straight length of belt, and it's like a bicycle chain. And what you can do with that bicycle chain, you can drop it down underneath the pulley like that and up, and then join it at the top, join the two bits together at the top, and then let it settle back down. As long as you've got the same kind of belt, the link belt, and you've got the same number of links in each of the two belts, then there shouldn't be a problem. So that's what I'm going to do, because that, if I get two straight chains, proper chains as it were, T-link belting, I can just drop it down into the headstock, round this bottom pulley here, pull it back up, joint it across the top, and let it settle into the horizontal position, or as horizontal as possible. So what I intend to do with mine, I have already put a piece of cable into the bottom of this V here and wrapped it underneath. So I've dropped the cable down into the machine under this pulley here and back up, and then I've marked the two there, cut it, and that's the length that I need, or the approximate length that I need for the full belt. So my intention now, when I go into the garage, is to, bearing in mind I've already got a belt sat on this one here, what I intend to do now is put a temporary strap holding these two pulleys together at the height that they're currently at, and then I will cut this belt, which is one of the original full belts. It's not a link belt, it's a full belt, so I'll have to cut that belt then in the middle, remove that belt into a straight line, and then I will make my T-link belt the same size, the same length as the belt that I've then removed, and I will put that belt in there, etc. And what I can do, I could, if I needed to, loosen this bearing off here such that I can pull this shaft up a little bit like that to shorten the length effectively between the two, such that I can link the belt together and then allow it to drop back down. And I'll have a permanent support on this one all the time. Whilst I'm changing this one, I'll have some kind of a rope or wire system holding this one together such that it never drops uncontrollably, because I want to maintain somewhere near that horizontal line that's across there. But as I said, on this end there is no bearing into the lathe. The shaft ends short of the side of the lathe, and the bearing that's holding all that in place is this belt from there to there. So that's what I intend to do. I'm going to tie something temporarily around this one to hold it in its current position. Then I will cut this belt here and remove it. I will then make the T-link belting the same length as the belt I've just taken off and cut. Then I'll loop that in and join it at the top, and then if necessary allow this to come back down somewhat into the position where it was before. And this is A section T-link belting. Now Tony also sells the T-link belting in addition to the proper fixed belts that you can buy, but to get the proper fixed belting you would have to dismantle all of this. Well, I'm not prepared to do that in my case, so I'm going with the T-link belt. So I hope that makes sense, and we'll go into it a little bit more when we get into the garage, what's going on. But I'll show you the T-link belting now, and then you'll know what I'm actually talking about. So this then is the T-link belting, and I've actually bought 2 lengths of this because it comes in a metre length. So a metre's far more than we need. I should be throwing some away, but that's what they are. They are just individual links like that, and the tag here comes through the holes in one of the other belts, in one of the other links, forming like a bicycle chain like that. So what I will do, I'll feed this into the top of the lathe, down, round the bottom pulley, back up, and then connect it at the top with this T-link belt arrangement. I'll connect it like that. Now I've bought this from my local engineering firm where I buy many of my tools, and that's RDG Tools. They're in West Yorkshire, and I've got that from them, and that was the cheapest that I saw it for sale. And having said that, I've got it, it is far more plasticky than I perhaps expected it to be, but it will be industrial standard, so I don't see that being a problem in fairness. But most of the other belts that I've seen are a more sewn canvasy type belt, more of a fibre type belt, which might give better grip on the side wall of these pulleys. I'm not really sure, because it's the side wall of the pulleys that it actually runs on. It doesn't run down in the bottom of the V, etc. So you don't get the bang 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 from these tags. It runs on this side wall, which is all quite well machined up. But as I said, it is plasticky in feel, but probably it should be quite good enough, because if RDG sell it, then it's good enough. And I'm just pointing out that to the feel it is actually more plasticky than the much more expensive belts, which are more of a canvasy type material. So just thought I'd let you know that. But yeah, RDG Tools, that's where I got this from. And I'm going to try this belt and we'll see how we go with it.